Good afternoon, this is Charles Walker from Oceanside Photo and Telescope. Today we're going to be talking about doing T-points in the TheSkyX Pro. Now you can see that I'm doing this on a Mac, but the process is identical whether it's Mac or Windows. So this is a very fresh installation of the TheSkyX Pro on this Mac. This is Software Bisque's new version of the TheSkyX Pro, and I would strongly suggest that if you're running an earlier version, that you upgrade to 10.5. At this point, we need to create a location file for the area that we're going to be imaging from. We can do this by opening up the Input menu button at the top and choosing Location. In this window, we're going to go to the Custom tab, and we'll enter in a location for whatever your observing location is. In this case, it'll be OPT. And then you can use whatever latitude and longitude device that you'd like to use, whether it's a GPS, Google Maps, or anything else, to figure out what your latitude and longitude is. These entry boxes are very forgiving. You can enter the numbers in by degree, minute, second, or by decimal format. In this case, we'll use decimal format. So OPT is located at 33.198113 latitude and negative 117.376267. And you can see that these values are automatically turned into degree, minute, second. Now we're very close to the ocean. We're probably about 33 meters above the surface of the ocean, so I'll put in 33 meters. At this point, we'll add this to our location database. We'll go to the List of Locations tab, to My Custom Locations, highlight OPT, and you'll see it appear down at the bottom. We'll set this as My Location, and then close this window. Now create a horizon drawing to keep T-points from trying to take samples through the back of your house or your neighbor's pine tree. So we're going to go to the Display menu button at the top, go down to Horizon and Atmosphere options. We should be on the Horizon tab. You want to make sure that Show Horizon is checked, and we'll go to the middle where it says Horizon Type. We're going to change Photograph to Custom Drawn. Now, this is just a make-believe horizon that I drew. I would suggest that in your backyard or your observing site, you use some kind of app on your phone or iPad or tablet. My favorite is one called Theodolite, and if you take altitude angles about every 30 degrees around your observing site, you can come up with a fairly accurate horizon map for T-point. And the easiest way to do this, and this drawing screen is very forgiving, you can go to, say, 36 degrees, and whatever your altitude is there, just draw a tick mark. And keep doing that all the way around your yard, like so, whatever your numbers happen to be. And then once you have all these peaks drawn, you can just start at the left and draw peak to peak. Once you've got your drawing in place, hit the Apply button. Let's turn Horizon Type back to Photograph. And my favorite photograph happens to be Desert because it's the flattest of all of the horizon photos, and it opens up more of the sky chart. So I'll leave this at Desert, and we'll hit the Close button. So now we have our location and our horizon set. Now we need to create a field of view indicator so we know what our field of view looks like in the TheSkyX. And that's reached from the Display menu button at the top. We're going to go to Field of View Indicators. And you've got two tabs on this window, and you can see that I've already created a field of view for a Celestron C14 at f7 and a QSI 683 WSG. But let me show you how I got there. So I'll go ahead and delete that. On the Equipment tab, the first thing you want to do is hit Update from Web, This is going to bring in all of the new equipment from BISC that they've loaded in over the last several months. Go to the Telescope tab, or the Telescope drop-down, and we'll choose Celestron and drop that down, and we'll find the C14 at f7. If you double click that, you'll see that it moves it across the screen to the right side, and it will show up under My Telescopes as the Celestron C14. And we'll go back to the top and minimize telescopes, and now we're going to open up detectors, which is simply cameras. We'll scroll down to QSI. We'll find the QSI 683 WSG, highlight that. If you double click it, it'll move over to the right side, and you'll see it under the My Detectors category. All we have to do at this point is hit Create My FOVIs button. You can see that it's moved across to the right side on the My FOVIs tab. All we have to do at this point is check the box, and you can see that on the sky chart, this field of view indicator has appeared. So we can close. And the FOV indicator function is fairly handy for you if you want to try out different combinations of equipment and telescopes that you may be planning on purchasing in the future, or if you simply want to dream about some fantasy system that you've heard about and you want to see what their field of view is. So now let's go ahead and connect our equipment. Now we're doing this inside an office inside of Oceanside Photo and Telescope, so I am limited to using simulators, but the simulators function very, very closely to real equipment. You should see very little difference in this. So on the left-hand side of the screen, go to the Telescope tab. We're going to go to Mount Setup, and we're going to choose our mount. So on the left-hand side, under Imaging System, where you see Mount, double-click on that. And you can see that here are all the different BISC mounts available at the present time. We're going to go to Telescope Mount Simulator, hit the OK button, and then we can close this window. Next, we're going to go to Camera, the Camera Setup button. And the same thing, we'll go to the camera selection here. We can double click on that. We'll go to the Software BISC Camera Simulator. Hit the OK button, close this window. And the only other piece of equipment that we need for doing T-points is access to your filter wheel. So we'll go to Filter Wheel Setup, and again, Filter Wheel under Imaging System. Double click on that, and we'll choose the Software BISC Filter Wheel Simulator. So let's go ahead and connect the telescope. That's under the Startup button and Connect Telescope. Now, the one function that does not show up under the simulator is homing, and you must home your Paramount each time you turn it on. So in this case, I'm just going to please tell you to look for the home function in this drop-down and click it. A small window will pop up asking you if you really want to home your scope, and you should say yes. Next, we'll go to the Camera tab, and we'll connect the camera. And under Filter Wheel, you can see that in the background, turning on the camera has already turned on the filter wheel. Now, T-points should be done with either no filter in place, a clear filter, or a luminance. So we're going to go ahead and choose the luminance and tell the filter wheel to move to the luminance filter now. So if you didn't know, the home position for Paramounts is on the deck 0 line on the west side and pointed up at about 53 degrees. So we're going to start here looking west, and I'll just scroll up in the sky and pick an area about 53 degrees up. And on the Telescope tab, I'll command the scope to slew to this spot in the sky. So now we're pointed very close to what is the home position for a Paramount. Once you've reached there, we'll go ahead and take an image with our camera. Now, for general T-pointing, and this setting will work for most of the cameras and systems on the market, set the exposure time at 5 seconds. For right now, we'll set 0 exposure delay. We'll turn our binning to 3x3. The frame should be light. Reduction will be auto dark. I want to make sure that subframe is not checked. automatically save photos is a mandatory check. And today we're going to be simulating our images using the Deep Sky survey. So you're going to want to check this box if you're using the simulators. And using the simulators is good for practice. Now when you're finished, and this is very important, when you're finished using the simulator and you want to start taking real photos with your real camera, you must uncheck this box. Otherwise, the TheSkyX will continue to try and download images from the internet. And like we said earlier, the filter wheel is set to luminance. So let's go ahead and return to the Camera Add-on tab, and we're going to take an image. So just simply hit the Take Photo button. We'll wait for the image to download from the Deep Sky survey. And this is the TheSkyX Fits Viewer. There are two ways to send this to ImageLink, which is the TheSkyX's plate solving function. You can either go to the Photo button here at the top and choose To ImageLink, or you can right-click on the image itself and choose To ImageLink. This is the ImageLink window. This window can also be reached from the Tools menu button at the top, and then you would just simply go to the To ImageLink window. There are 4 tabs at the top. For the moment, we're going to be concerned with the All Sky tab. And for your very first image link, you should set this to blind, this first radio button, and then check all 3 boxes down at the bottom. And then we're going to hit the All Sky Search button. And in a couple of seconds, we should get our first successful image link. And there we go. You can see how the screen rotated, and we got a shutter click sound, and the white box represents what our camera is actually seeing from the Deep Sky survey. Now there are a couple of things that we need to do now since we've received our astrometric solution. The first thing is we need to make note of our image scale. So right now we are at 5.1 arc seconds per pixel. What we're going to do, since we now have a known image scale, is we're going to go to the Known Image Scale radio button, and we're going to change image scale to 5.1. On the mirror option, about 99% of the scopes and cameras on the market right now, you're going to choose Photo is Not Mirrored. Now we can check our settings by hitting the All Sky Search button again. And if you get another solution, that means that your settings above are correct. Now we're going to go to the Setup tab. Now, the rotation and shutter click are fun to watch, but if you're doing a large number of T-points, it eats up about 1 second in time for that little animation to occur. If you're doing 300 plus T-points, you could be looking at an additional 5 minutes worth of time just to watch your screen rotate and listen for the shutter click. So I would, when you get tired of that, change type of animation to none. Now we're going to go down to the Automated Image Link Settings button, and we're going to enter in the exposure time and the image scale that we learned earlier, so 5.1 arc seconds per pixel. We're going to change our binning to 3x3. We're going to set our filter at luminance. We want to leave search area set at 2 fields of view, and we want to leave retries set at 2 per target. Check the Use All Sky Image Link for Automated Pointing Runs checkbox here, and hit the OK button. On the FOVI Options tab is the checkbox for Rotate FOVIs to Computed Position Angle. We want to make sure that's checked. So let's go ahead and close this down and take another photo just for practice. Okay, it's downloaded from the DSS. So we'll go to the Photo button at the top, click To Image Link. We'll hit the All Sky tab and then the All Sky Search button. And you can see now that very, very rapidly we have an image link solution for our T-points. So now we can close the image link window, and we're going to open up T-points. That's found on the Telescope menu button at the top and the TPoint add-on. So there are 6 tabs at the top. The tab that we're concerned about now is the Calibration Run tab. We want to go ahead and hit the Start button. We want to run a full calibration. You can also see here in the middle that there are entries for temperature, pressure, and humidity. These can be very helpful in figuring out light refraction at your particular viewing site, but if you don't have these available, just leave them at the defaults. And in fact, there is a default button down here if you've played with these numbers, but you're not quite sure what you've done. And we're going to go ahead and hit the OK button at the bottom. And then we're going to move to the Automated Calibration button. You want to go ahead and have this on the Setup tab. And we should have the same settings that we just entered into the image link window here on the Automated Pointing Calibration Run window. So 5 seconds, 5.1 arc seconds per pixel, 3x3 binning, luminance filter, 2 fields of view, retries to, use All Sky Image Link for automated pointing runs checked. And just to make sure that these settings are good for image linking and T-pointing, let's go ahead and hit this button down at the bottom. Okay, so it successfully image linked this image, and it's asking you if you'd like to go ahead and use this particular image scale. We want to hit yes. We can also close out this image for the moment. Then we'll go to Create Pointing Targets tab. Now, on the bottom left of the screen, we'll want to check Randomize, Clip at Horizon, which will prevent T-points from trying to take images through the back of your house. We do not want to check Sort for Dome, and finally check Interactive Grid. Now, there are 4 orange dots on this blue circle in the middle. If you take the orange dot on the left, you see that it slides in and out, and this is tied to the altitude start line over here on the left. And let's move this in until we get to about 25 degrees. Close enough. Now the orange dot in the middle, we'll move this in and out, and you can see that it's tied to the altitude end line on the left, and we'll get this to as close to 90 as we can. 89.1 is good. Grab the upper left orange button and you can see that it's tied to the azimuth start line. We'll want to get that as close to 0 as we can. 0.9 is fine. Now grab the upper right and we'll get this as close to 360. 359.1 is just fine. If we go to the slider down at the bottom, this is where we set the number of samples that we would like to take. Now for a polar alignment, something in the mid-40s works very well. You can't actually choose the number you want, and in this case it appears on the number line at the top, but you can get fairly close, and in this case we'll do 49. Finally, we go to the Acquire Pointing Samples tab, and this is where T-point begins. Simply hit the Run button at the bottom. Now if you have a camera that downloads fairly rapidly, you can get up to about 3 T-points per minute. If you're doing 49 T-points, that would take about 16 minutes. If your download times are slower than this, it could take a little bit longer. So now you see that we're actually starting to add T-points. Now one thing we can do is declutter our screen a little bit. So we can slide this window all the way to the left. We can take the Images window, or the Fits viewer, and move it all the way to the right. And this will open up our T-point window. And what we can do at this point is on the T-point window, go to the Model tab, and this is where you're going to find Supermodel. This is a function that cleans up the outliers that occur when you're T-pointing. So after we get about 12 samples, we're going to hit the Supermodel button in the middle at the bottom of the T-point window. Now one thing that you'll see by using a simulator is that our T-pointing is artificially good. You can tell that in the representation here for pointing accuracy, that our pointing is 1.5 arc seconds. And what you'll see in real life is that before you've done your first supermodel, your pointing error is really along the line of 60 to 90 to 120 arc seconds in error. Really nothing to be worried about. Once you hit the supermodel button, those numbers will clean up considerably. So now we have 12 samples taken. We're going to go ahead and hit the supermodel button. Once you get your result, just go ahead and hit the apply, and that's our first supermodel. I like to take a supermodel after the first 12 samples, and then about halfway through, and then once again at the end. So now that we've run half the samples, I'm going to go ahead and hit the supermodel button one more time, hit the apply button, and then we'll let the sample run finish. So you can see now that the samples have finished being taken. You kind of have to watch for this because there's really no indication when T-pointing is finished. So now that we're done, we're going to go back to the Model tab and hit the Supermodel button one more time. And this could take, depending on the speed of your computer, several seconds for it to calculate. We'll go ahead and hit the Apply button. Now we're going to return to the Calibration Run tab, hit the Finish button, and now we're going to go to the Polar Alignment tab. Now, there's one difference between running T-points and polar alignment with the simulator and doing it in real life, is that when we use the simulator, right off the bat, we get artificially excellent results. And we're also missing a couple of lines of text out of the azimuth and elevation choices here. So what you're going to see on the azimuth line is what I call turns advice down here at the bottom. And on a paramount, there's a sentence down here that will tell you exactly how many turns to do with your knobs. So for instance, it will say loosen the right knob 5 ticks and tighten the left knob 5 ticks. On the elevation section, it will say raise the elevation knob 17 ticks. And those are very, very accurate recommendations, and we'll get to those actually in a minute. So what we're going to do now is a function called Accurate Polar Alignment. And this is a relatively new addition to the TheSkyX Pro. It's a very, very accurate way to polar align your telescope. So before we get started on that, we're going to be doing just a little bit of housekeeping. So we can close the sample window over here on the left. And let's move the T-point window away and move the Fits viewer away a little bit. So let's go ahead and hit the Accurate Polar Alignment button. It brings up a window that appeared in the back. So let's move the T-point window around. We'll move this window down here and bring the Fits view over. So let's just go ahead and click through the screens. This first screen just says it's going to guide you through the process. It's now verified our pointing model. We'll click Next. And now the TheSkyX has the ability to show you a list of stars that are acceptable for polar alignment, or you can choose your own star. I would suggest you hit the Show Me a List of Stars button. So on this screen, you can see that the TheSkyX has provided us with a list of suitable stars. Let's just go ahead and choose the first one, and we'll command the scope to slew to Fomalhaut. We'll right-click on that star and hit the slew command. And now we'll wait for the scope to slew over to the target, and we know when it's stopped slewing, when it just shows that we're connected again. So now that we're centered on Fomalhaut, let's go to the Camera tab, and we'll take a photo. And you can see that we're centered on the star. So for the next part of the process, let's stay on the Camera Add-on tab. We're going to go to Focus Tools. On Focus Tools, we're going to set our exposure time at 1 second, bending 3x3, light frame, auto dark, and take photo continuously. Want to check automatically save photos, and for this purpose we're also going to have simulate photos using DSS checked. So let's go ahead and start taking continuous photos of this star. Now let's return to the Accurate Polar Alignment window, and once we're starting to take continuous photos of the star, we're going to hit the Next button. What that's going to do is cause the mount to slew the distance that is equal to the turns that you saw on the polar alignment report. Now again, because we're using the simulator, you're not going to see the star in our image move, but in fact that's what happens. So we'll hit the Next button, and the star will have slewed off center. And now what you do is point your laptop or your computer screen toward the mount so you can see the Fits viewer. You're going to walk up to the mount and start turning the azimuth knobs and the altitude knobs until you center the star back up on these crosshairs. And here's the crosshairs. It's good to keep in mind that the azimuth knobs will usually move the star up and down, and the altitude knob will move the star left and right. So once you have the star centered back up on the crosshairs, come back to the accurate polar alignment window, hit the next button, and now the finish button. And you're complete with T-points, and you're complete with your accurate polar alignment. So we can return to the camera add-on tab. To stop it from taking pictures, we'll just go ahead and hit the abort button, and then return to the Take Photo tab in the camera add-on. This concludes T-points. This has been Charles Walker from Oceanside Photo and Telescope. Feel free to call me at the store if you have any questions about T-pointing or any other questions about the TheSkyX Pro, or you can email me at charlesw@optcorp.com. Thank you.
Hey, this is Stephen Hendren from OPT. Hope you enjoyed the video. If you did, be sure to like, comment, and subscribe for more. We also have some links to some other videos you might enjoy. Also, be sure to check out optcorp.com for all of our fine astronomy products. Have a nice day, and keep looking up.